Hello everyone, hope all of you are doing great, and in today's video we're going to have a look at the workbook for lesson 1.2, which is all about standard form. We're going to discuss all the questions in this homework, but before you watch the video and before we proceed, I would like you first to remember what you're supposed to do. First thing that you're supposed to do is just to study the notes. So that's the first thing. Study the notes that you already have. The second thing is to answer homework section per section. So you divide the homework into sections. For example, the first four questions here, let's consider them. The first section, you need to answer them. After that, you go to the answer key, the mark scheme, and you start correcting the first section to avoid the repetition of mistakes. Done with the third, then, Mr. I finished the homework, I finished marking all of it, but I have a few questions that I do not understand, or I have a lot of questions that I do not understand. Come to this video and watch for those questions that you do not understand. Mister, the video is long. There is no need to watch the whole video. If you would like to just head to the questions that you do not understand, it's not going to be a problem at all. Just watch for the mistakes that you do not understand. Let's start the video, not to take up so much of your time. All right, the first thing that we have over here, we are going to answer the first question. Let's see here, write these numbers in standard form. All right, here I got question A, B, C, D. All of them have the same. We're gonna follow the same strategy. We're gonna follow the same technique exactly. There is no difference between each one of them. So I'm gonna answer only one of them, which is question D. It is 208. Well, it is actually 20,800,000. 20,800,000. And then you need us to write this in the standard form. Okay, let's remember and remind each other what is the standard form. Standard form to be written, I need a number, this number to be between 1 and 10. So it must be a times 10 to the power of n, where a is any number, is that number, but it's between 1 and 10. And n is an integer. It can be negative, it can be positive. It doesn't matter. The most important thing is that it is a whole number. All right, so for a to be written, which is a number between 1 and 10, I need this to be 2.08. That's the only way to make it between 1 and 10. Great, times 10 to the power of, well, Mister, I need to move the decimal point here how many times to make it 2.08? Well, the decimal point originally was here, hiding at the end of the number. Always, Mister, always hides there. Some of you get confused and they say the decimal point is here. No, that's not right. The decimal point is written at the very end of the number, over here. Great. Let's see over here. How many times did I move the decimal point until it reached 2.08? Let's count. 1, 2, 3, 4, 5, 6, 7. Great. So what is it going to be? 2.08. 2.08 times 10 to the power of what? We said how many times? Exactly, we agreed it is going to be 7 times. So it is to the power of 7. Oh, Mister, is it always going to be to the power of 7? Not always. It might be sometimes to the power of negative 7. Oh, but Mister, how can I tell? Well, if you move the decimal point to the left, then the power is going to be positive power. But if you move the decimal point to the right, it's going to be a negative power. Here, I move the decimal point 1, 2, 3, 4, 5, 6, 7 digits to the left, so it's going to be positive 7. That's it. The same thing exactly with the first question, the other three numbers, and the question two also the same thing for the first one over here. But starting here, B, C, and D, it is a little bit different. Why, Mister? Because they didn't write the whole thing in digits. They wrote 640 million. So how can I write this? How can I do it? Let's see. How can we do that? So here, question C, for example, they say to you 640 million. And we need to write this in the standard form. So what are we supposed to do? Same thing exactly. 6.4. Oh, but Mister, can I write it in digits first? Because I just get confused. No problem. All right. So if I say to you here, this 640 million, how can we write it in digits? It's going to be 640 and six zeros. 1, 2, 3, 1, 2, 3. Great. Now I can answer it, mister. Good, good. Let's do it. So here I'm going to do it 6.4 because I need a number that is between 1 and 10 times 10 to the power of, let's see. I moved to the decimal point from here. 1, 2, 3, 4, 5, 6, 7, 8. I moved it to Mr. 8 digits to the left. So it is going to be positive 8 because we agreed left is positive power. So it's 6.4 times 10 to the power of 8. All right. Now we're going to need to move to the next page. Just a second. Let me remove this. All right. The second question here says to you, these numbers are in the standard form already, but they want you to write each one of them in full. How can I write them in full? Let's see. To write them in full, so the first one, for example, here, let's take this example, and the rest are exactly the same. Question C, 7.11 times 10 to the power of 11. What are we supposed to do, mister? You're supposed to answer it. Just multiply normally. So as if you're multiplying by, it is 11 zeros. So in multiplication, you took this in year 5, you took it in year 6, you took it in year 7. If I'm going to multiply by 10, for example, let's assume it's 7.11, multiply by 10. You took that, you're going to move the decimal point to 1 digit to the right. We took this. Multiplication, you move it to the right. So it's going to become 71.1, mister. Great. And if it was 7.11 divided by 10, you would do what? I would must have moved the decimal point to the left. So it would be 0.711. Excellent. Good. But here, they're not asking you to multiply by 10. They are asking you to multiply by 10 to the power of 11. How can we do this? Great. Yes, we're going to move the decimal point here 11 times. Whoa, that is a lot. Yes, I know, but it's easy. Good. So let's do it. I'm going to move the decimal point 11 times to the right as we agree because it's multiplication. So I have here already 2 digits already to the right. So how many more do I need to add? I need to add 9 more digits. I already have 2, so I need 9 more. So it's going to become what? It's going to be 7, 11, and I need 9 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? That's it. But, all right, mister. Here, if I have another question, let's answer, for example, 1.331 times 10 to the power of 8. Let's go. Here we go. They're saying 1.331 times 10 to the power of 8. The same thing, mister. It's multiplication. I'm going to move the decimal point to the right, but 8 digits to the right. I already have 3 digits to the right, so I need to add 5 more. So it's going to be 1.331. Oh, sorry. It's going to be 1, 3, 3, 1. Now I move the 3 digits to the right. Yes, but I need 5 more. So 1, 2, 3, 4, 5. That's the answer. Now I moved to the decimal point 8 digits to the right. I had 3 already written there, so I needed 5 more digits to be written. Great. Let's continue. Question 4 here says what? Question 4 says to you, a light year is the distance light travels in 1 year. 1 light year is this big number. Write this distance in standard form. How can I write this distance in standard form? Well, let's write it over here, or let's answer it right away instead of just copying the number. Good. So to write it in the standard form, mister, I need it to be 9.46. 9.46. Great. Okay, no problem at all. Why? Because I need it to be between 1 and 10. Done, mister. Times 10 to the power of, I need to see how many digits. I moved to the decimal point. The decimal point was here. Well, Mister, I know that these are 3 digits, 6 digits, 9 digits, 12 digits. So I moved it, Mister, 12 digits to the left. So to the power of 12. To the left means positive power. Let's continue. Here, go down. Oops, went down too much. Just a second. Here we go. All right. Question 5 says to you here what? Write these numbers in standard form. Good. All right. So the number is what? The number is 0.00403. Okay, and they want in the center form. Mister, I'm gonna need to move it to the right this time, not to the left. So in order until you make it 3, so I need this to be 3. 3 times 10 to the power of, Mister, I moved it 1, 2, 3, 4, 5 times to the right. To the right, it means -5. Good? Okay, great. And the rest are exactly the same as question A. Question 6. It says to you, these numbers are in standard form already. Write each in full. We're just doing this right now, but there is a difference. So let's write the question. It says to you here, 1.5 multiplied by 10 to the power of -3. They want you to write it in full. Good. How can I do this? Mister, I'm gonna do like what you said, but you told us, Mister, and we learned in year 5 and in year 6 and in year 7 that in multiplying it by the powers of 10, we move the decimal point to the right. Yeah, that was awesome. And what was taught to you is perfect. But here I have a negative power. So it is as if you're dividing it by 10 to the power of 3, which means I'm going to move the decimal point, but to the left. How many digits? 3 digits. So 1, I already have 1. I need 2 more, then put the point. 5, I have already 1 digit, but I need 2 more, Mister. Then put the point. Thank you. Let's answer another question here. Let's say, for example, 1.234, 1.234 times 10 to the power of -5. Let's do it. Here, how are we supposed to answer this? They want you to write it in full. So, okay, Mister, this is multiplication. I'm going to move it to the right. Oh, but there is a negative power. So I'm going to move it to the left. Good. That's how we do it. But how many digits to the left? Let's just first write 432. They're not going to be touched. All right, I need to move it, Mister, 5 digits to the left. I already have 1 digit. I need 4 more digits. Then I put the decimal point. That is it. And the rest of the questions are exactly the same. Good? All right. So question 7 here says to you, write these numbers also in full, the same thing exactly as in question 6. No difference at all. Question 8 says, the wavelength of visible light is between this and this. Good? Let's just go to your another page, a new page. All right. It says to you here, write each of these numbers in a standard form. The same thing exactly. So they said, Mr. 0 point, I have 6 zeros and then 4. I need Mr. this to be 4. This is going to be 4 times 10 to the power of, I moved it, Mr. to the right, so definitely negative. Here I have 3 digits. Here I have 6 digits. I brought it over here, so it's going to be 7 digits. So 4 times 10 to the power of -7. While here, I moved it to Mr. 3 digits, 6 digits, 7 digits. So it's also Mr. 8 times 10 to the power of -7. This is question 8. Question 9 says to you here, write the numbers in order of size, smallest first. How can we do this? We took all of this in the class, everyone, and all of this is written to you in the notes and explained to you also in the notes. All right, question 9 here says to you, arrange them in order from smallest to largest. So in order to do that, we need first to compare the powers. Very good. After we compare the powers, let's see what we're supposed to do. So, which power is the smallest? I got -7, -6, -7, -6, -7. The smallest power is -7. This is the smallest power. Good. But, mister, there's a small problem. What is the small problem that you have? All right, here I have a Mr. -7. I have -7 here. I have -7 there. Which one is the smallest? Well, the smallest is actually the one that has the smallest number over here. So here I have 5.17, and here I have 9.8, and here I have 3.05. Oh, C is the smallest semester. Exactly. So C is the smallest. And what else? What is after it? Well, I got after that here 5.17, 9.8. Oh, mister, it's 5.17 definitely, which is E. Great. So now I'm done with C. I'm done with E. After that, oh, I got only A right now that is left. So I got A. Thank you. Good. But I got after that B and D. Which one am I going to take? Which one is smaller? Oh, both of them have a power of -6. Yeah, so look at the number that is written over there. 1.2, 4.81. Well, it is 1.2. So I'm going to write here B. And the greatest of them all is going to be D. D is the greatest number. So again, as we agreed, it's going to be C, then we're going to have E, then we're going to have A, then I'm going to go to the power of -6, B, and the largest is D. All right, now we're going to go to the challenge section. It says to you the mass of Earth is like this. When you write this mass in full, how many zeros does it have? Mister, do I really need to answer it? For God's sake, please, mister, don't say that I need to answer this and write it in full. No, you don't need to, but you're gonna need to assume as if you're really doing it. So if I have here times 10 to the power of 24, how am I supposed to write this in full? Oh, Mr. Okay, multiplication and positive power. I'm gonna move the decimal point to the right. Okay, great. How many digits to the right? Unfortunately, Mr. 24 digits to the right. No problem at all. So I'm gonna need one digit I already have, two digits that I already have. How many more digits do I need? How many more zeros do I need? I need 22 more zeros because I need to move the decimal point 24 times to the right. But I already have 2 times written for me here, so I need 22 more times, which means 22 zeros. Good? All right. B. B says to you the mass of Mars is approximately 1/10 of the mass of Earth. How can I find the mass of Mars? Okay, so write the mass. Now, what is 1/10 of a standard form? We agreed before, and it's written to you in the notes. If you want 1/10 of a standard form, what are you supposed to do? Reduce the power only by 1. So it's going to be 5.98 times 10 to the power of 23. Now I got 1/10 of the standard form. Good. That's all about question 10. Question 11. It says to you here, copy and complete this sentence. 6.2 times 10 to the power of 7 is what? Is how many times larger than this? 6.2 times 10 to the power of 7 is how many times larger than 6.2 times 10 to the power of 6? Don't say it is one time, mister. No, wrong. It is not one time. It is 10 to the power of 1 times larger. 10 to the power of 1 times larger? Yes. 10 to the power of 1 times larger, which actually means just 10. So it is 10 times larger than this. Good? But here in question B says to How many times larger than 8.5 times 10 to the power of negative 3 is 8.5 times 10 to the power of 3? 8.5 times 10 to the power of 3 is how many times larger than this? Okay, mister, I need to find the difference between the powers. So here it's how many times it is, mister, 10 to the power of, oh, between the 3 and the negative 3, I have 6. So the difference between 3 and negative 3, as if you're just imagine the number line. Literally, imagine the number line. I go here negative 3, I got here the 0, I got here the 3. I have a Mr. 3 numbers until here. I have 3 numbers until there. So the difference between negative 3 and 3 is just 6. Good? So Mr. is going to be 10 to the power of 6 times larger. So it is 10 to the power of 6 larger. Or, Mr., can I say 1 million? No problem at all. Yes, you can say 1 million times larger. Yes, this is also possible. Great. Okay. So let's continue. Not that much. Come on. All right. Here, question 12. It says to you these numbers are not in the standard form. They want them to be in the standard form. No problem, mister. 4.5, we agreed that 45 needs to be between 1 and 10. So it's going to be 4.5. You multiply by 10 to the power of, oh, mister, you moved it 1 digit to the left. So I need to add 1 to the power. It's positive 1, not add 1. It's positive 1. So 6 positive 1 is positive 7. All right, over here, what I'm supposed to do? Here, mister, I'm going to move the decimal point in question D. I'm going to need to make it 9.95 times 10 to the power of, oh, 1 second, mister. It is already to the power of 7, but I moved the decimal point to 2 digits to the left, so it is positive 2. All right, so 7 plus 2, okay, is going to be 9.95 times 10 to the power of 9. I added 2 to the 7. Why? Because I moved to the decimal point to 2 digits to the left. Question 13. It says you also they want this in the standard form. Good. Here, I'm going to need to move the decimal point twice to the right. So 1, 2, so that it becomes 8 times. Well, here, I move the 2 digits to the right, then I need to minus, it's negative 2, Mr. We agreed. If I move the decimal point to the right to make it into standard form, it means negative 2. So but I have already negative 7, so it is negative 2 minus 7 minus 2. Negative 7 minus 2 is 10 to the power of negative 9. Minus 7 minus 2, or negative 7 minus 2 is negative 9. That's it. Okay, the last question in today's lesson. Here, if they want you to do the addition, it is that simple. Look at question D over here. You just need to write times 10 to the power of negative 5 as it is, without any changes, times 10 to the power of negative 5. It's the same here, the same there, just I'm going to write it once. And what about the 8.6 and the 2.86? These are the two numbers that you need to add. So 2.86 plus 8.6 is going to give you exactly 11.46. I hope I didn't make any mistakes. All right, so here it's 11.46 times 10 to the power of negative 5. If I leave it this way, it is wrong. Why, mister? Oh, wallahi, I just added 8.6 and 2.86. It gave me exactly 11.46. Yes, it is right, times 10 to the power of negative 5, but they wanted the answer to be in standard form. Is this in the standard form? Uh-oh, 11 point. No way, mister. Standard form, this needs to be between 1 and 10. So definitely it is not standard form. Make it into standard form. Move the decimal point once to the left. So it's going to become 1.146 times 10 to the power of negative 5. No, come on. I moved it 1 digit to the left, so it means positive 1, so it becomes to the power of negative 4. So 1.146 times 10 to the power of negative 4. That's it. Thank you so much, everybody, for watching the video, and see you in another video.